my name is Mike Burns. I'm president of Pioneer Exploration Consultants. You'll see a story of our company here in the talk, so maybe I'll sort of delay my introduction because you'll get it here. So I was looking for a picture to put up that kind of spoke 1,000 words, and I always like a story. And last night I was looking for a good title picture, and I came across this one, and I could not figure out why I was so happy in that picture. I knew where it was taken, I knew when it was taken, but why I was smiling was a big mystery. And then it dawned on me, I got to go home early. So there's some rare gems in in the drone geophysics survey industry when you get a break from field work. So the crew luckily just had to bust some scratches out and they're up and running again, but I got to take a flight home. So who we are, Pioneer Exploration it was started as a exploration consulting company. We all have geology or geophysical backgrounds. I'm joined in ownership of the company by three amazing colleagues, Mac, Kia, and Andrew. Kia is our chief geophysicist. He's here today with me as well. We have 11 field staff in addition to that, as well as some office support. And we really built the company on a flat management structure. And what we wanted to do is create a culture of ownership and excellence and have minimal turnover. So we held on to people for a long time. And that's really critical in this industry because the lessons that you learn over years of doing drone surveys, if you're careful and you're meticulous and you build off of your mistakes and you apply those lessons to your future operations, you can see a significant reduction in risk and reduction in incidents and increase in safety margin. And all of this leads into a more profitable, more reliable service provider business model. So that's what we've done. And we're very fortunate to have a extremely experienced survey crew, as well as management. And part of the key to that is that we really support the hell out of the guys that are in the field. All of us have been from various backgrounds, but myself, Mac, Kia, and Andrew, as owners of the company, we routinely are in the field ourselves. So we know exactly what it means to get a snowmobile unstuck or change a flat tire or fly a drone. And the focus of the company is on data quality and customer support. So at the end of the day, when you deliver data to the customer or to our mining clients, they don't care that it was flown by a drone when they're sitting down and looking at it on ARC or on another Leapfrog or another GIS platform. They just care about the quality of that data. So that's where we put our effort into making sure we deliver the best data possible. Our business was built on, like I mentioned before, serving those mining clients. We do a few different methods and provide a few services to do that, namely drone-based mag. That's sort of our core business still to this day. But we've recently onboarded other survey types, and that includes hyperspectral. That's that large drone there in the bottom left. That's about a 12 kilogram sensor, so a fairly heavy payload that was recently flown here about a month ago. We also have LiDAR. LiDAR we fly quite a bit. It's a survey type that's becoming more popular for a lot of our clients, so we'll oftentimes have requests for both MAG and LiDAR or other survey methods. And we've taken the route of flying mostly manned airborne LiDAR surveys rather than drone. And there's a couple of reasons for that. I'm happy to go into them. But we found this a very effective method to cover those remote, larger areas that typically we're tasked with doing. So where we work, over 9 years of MAG surveys, we've hit about 14 countries. We have hundreds of clients and in total have flown hundreds of thousands of line kilometers of survey data. It seemed like pretty big numbers, but we're really just getting started in this space. Over a couple of years of growth, the early years were rapid increase in capacity and technology and seeing just how fast we could keep pace with what was going on in the sector. And then the last couple of years are really where the businesses started taking off, and we're getting into a really routine workflow and able to really see the benefits of the culture we've created within Pioneer. But the big question that is, how did this all happen? And that's kind of the story that I wanted to tell you guys today. We've done fairly technical talks, and our Geophysics key has presented at PDAC and at KEGS and other symposiums on more of the data side. But I thought I'd give you guys a overview of how we entered into this business and some of the key elements that brought to our success. And please don't take notes, because this is not a routine way that you should consider entering into the drone geophysics space. And you'll see what I mean when I get there. But our start happened in 2013. I was doing my master's in economic geology at Laurentian, moved back to Saskatchewan, and finished up there, and started a company at the same time with 3 colleagues, one of which was a former master's student with me. We shared an office in Sudbury. So the company was formed, and we focused on exploration services. We wanted to be the consultant geologist to mining companies and projects, and drill campaigns, and do all of that fun stuff, which was in our backgrounds. I spent years in the Yukon as a greenfields geologist, and our other business partner had a vast amount of brownfields exploration. And then he said, "Hey, Mike, why don't we purchase a drone?" And I kind of hummed and hawed a little while, and I was eventually convinced, because we could do cool things like make our own ortho imagery for mapping. We could do pit and pile surveys. We could do promo stuff for companies, filming, photography. And then it was like, yeah, sure, this seems like no one else is doing it at the time. I mean, 2013 isn't that long ago, but in the drone space, that's like a couple generations back, right? So there was very little drone ecosystem or drones in the industry. We were one of the first that had a drone as a consulting company. And then Frank Wang ruined all my plans. So if you guys don't know that name, you should, because Frank Wang came up with a little company called DJI. And he launched the Phantom in 2013. And all of a sudden, all of our potential customers for ortho imagery and pit and pile surveys and all these cool things that we were promoting that we could do with our $60,000 drone, someone could go and buy their own pretty cheap and do it themselves. So it caused a bit of a rethink, and had to figure out a way to pay that debt off. So as any good geologist would do, I went into the basement and hung up my RC controller and grabbed my rock hammer and headed down to Montana to manage a gold mine. So my days were spent inside of this shipping container where I was running the operations for a company, but also in charge of all the gold recovery. So this is just a picture of a bump table that separates the heavy minerals from the gold. And it was during this time that I got to ponder my future and think about how the heck I was going to pay off that useless piece of carbon fiber sitting in my basement back at home. And then fortune would have it, the door swung open to the shipping container, and this guy popped in. And I'm not sure if you recognize him, the picture's a little bit slow, but that's Keith Barron. And Keith was responsible for the Fruta del Norte discovery in Ecuador, one of the richest gold mines that was discovered in South America, let alone the world. Keith was also a serial explorationist, so he had all sorts of different properties, and I didn't know who he was. He didn't know who I was, but I struck up a conversation and left the door to the gold room open and promptly took him on a tour of the mine. And then we started chatting about different stuff, and he said, "Oh, I recently purchased a sapphire mine just down the road from here, and it needs some exploration work done, but it's terrible terrain. You can't walk through it, and I'm sick and tired of paying those high mobilization fees for airborne geophysical surveys." And I said, "Well, I could probably do that with a drone." And his ears perked up a little bit, and he said, "Well, if you're interested, send me a proposal. So he gave me his business card, and I thought about it for a little while I was inside that shipping container sorting gold. And then did some research and started looking things up, and I thought, well, you know, if we rip that camera off of this drone and we attach one of these gem system sensors, which I think we had eventually purchased serial number 1, but at this stage we didn't own anything. We didn't own the mag sensor. I've never played around with this stuff before. This is all new. I thought we could probably pick that up with this drone. I know it's got a few more BTUs in the engines than that DJI thing does. So let's strap it on and see what happens. What could go wrong? So we purchased the mag sensor with the down payment on the survey that we were about to launch. I was in the US, the sensor was in Canada. The guys that brought it to me got turned around at the border. So I had a 14-hour drive north to try to get the sensor out of Canada into the US and go and fly a survey. So what could go wrong with this genius idea? And it turns out it was successful. Keith was happy. We flew the project, and it was actually kind of interesting. This property had been mined since the 1800s. And the source had never been discovered. So right in the middle of the survey grid was a nice big bullseye that was interpreted to be potentially a Lamprosphere and possibly the origin of the sapphires. So that was kind of an interesting way to start our very first mag survey, and completely by chance. Wasn't where we planned to go with Pioneer, but it quickly became our future. So the growth phase of the company started in 2014. At this stage, we quickly realized that the little multi-copter was just way out of its class in terms of the requests we were getting. I published a small paper on what we were up to, and almost the next day we had all the major companies like BHP, De Beers, Anglo American, all calling us, wanting us to come and fly a survey for them. So I quickly looked around and did some research and thought, well, we could probably use a bigger drone. So I called up a company that made these fancy looking single rotor helicopters and thought that's what we need for sure. They're pretty sexy looking. They've got a bigger payload, a lot more endurance, and that'll all lead to increased survey production. We can do a lot bigger areas, more line kilometers per day. This is what we need. This is perfect. But after 3 of the top helicopters, I'm not going to say their name, spectacularly disintegrated in midair, and the lower ones did the same. I kind of realized that the single rotor helicopters might not be the way to go. They were a lot more complex. They're accident prone. They were very expensive, like 6 figures expensive, and poorly supported with a great sales team, but they had complex supply chains as well. So if you just tip over and nick a component on any of these, your entire rotor head is ruined, your drivetrain is ruined. It's a write-off. So compare that with a multi-copter where you might replace a prop and be up and running again in 10 minutes. So we were really struggling at that point. And actually the first picture on the slide, I think I didn't have any choice but to smile there, because I was staring the end of our company straight in the face. And luckily, DJI came out with their M600. So Frank Wang stepped in and saved the day after all. And that was a complete revolution in multi-rotor technology. It really did change things. So just by a show of hands, those of you that are commercial operators or fly UAVs, how many of you operate M600s or M600 Pros? Or have in the past? So everybody pretty much, and they're discontinued, but look how many are still sitting out there on the benches. So this was a complete change in the direction that we went, and really opened up the potential for a company. They had a better payload than what we were using before. They had pretty good endurance. They really increased their survey production, but they also did something else. They were simple to use. So they allowed us to onboard new teams quite rapidly, because we weren't investing so much time in teaching people how to fly drones. We were focused on supporting more teams, a quick training, and really getting the capacity up to meet the demand that we were seeing. And that really led to to where we are now eventually. So in 2017, this is the stage where I say we had a real company. We were finally making money versus spending money. And that was a good place to be in because it let us start to experiment with new things internally versus sort of begging and getting loans and trying to fight our way through the ecosystem of a rapidly evolving tech sector. So we had a steady growth of clients, and that was really back to our focus of always providing high quality data. And right from the start, we always made the promise that if it's not up to our spec, which we use the Canadian Geological Survey airborne geophysical standards for our data acquisition specs, that we'd refly it at cost. So it would be on us to go down and refly the project. So we were able to increase our project capacity, so the number of capacities and also the size of the project. And going from a few hundred line kilometer jobs, we are now flying jobs that were 1,000 line kilometers or more sometimes, quite competitively. We had enough money to keep guys and attract new guys, but also do things that I felt was important, like give them extended health benefits, create a safety culture, really focus on the regulatory management and structure and organization within the company. And this is what really has let Pioneer significantly reduce risk in the drone space with our internal operations. You know, in the beginning, there was a lot of trial and error of different systems. There was a lot of unknowns. You kind of trusted the drone to come back every time when you took off and thought, oh, this thing's pretty smart. It's definitely not going to hit anything out there. But then you realize fairly fast that you as a user have probably 99% of the fault for anything that goes wrong. And when you have a system that's very consistent, you can start tracking those errors and little improvements or little protocols that are incorporated into your workflow can significantly prevent that from happening next time. And after 9 years of iterations that where we constantly, even today, are constantly updating how we fly our surveys, that's just seeing like a massive decline in risk level at our company. And then we're able to diversify. So we purchased a LiDAR sensor. We just purchased a new one. So now we have two LiDAR sensors. One is a VUX 1 Regal. The other one is a VUX 240 Regal. Both of those we fly on manned aircraft. The 240 is a little bit too big to fly on a drone. And its capacity is meant for larger scale work. But that was an exciting time for the company to be in this stage of we're comfortable, we can grow. What do we want to do going forward in the future? So where are we now? And this kind of goes back to what I said, but we're dealing with systems that are highly sensitive with less noise. We've seen an evolution in the sensor technology come on board. The drones have better terrain following capabilities. There's real-time terrain avoidance that some companies are using right now. There's, in terms of an active solution, there's other terrain avoidance where you use high quality DEMs. That goes back to our LiDAR surveys. Sometimes we'll do that. So early sense and avoid systems are becoming available. That's really exciting, and I think will lead into more type of BV loss capability as well. And we've also seen the updated regulations with increased scrutiny on safety and environmental impact. So in the early days when we started, we were flying internationally pretty much right off the bat. And several of the countries that we went to didn't have a organized drone regulation framework within their civil aviation authority. So we'd call up the Civil Aviation Authority of Guatemala, for instance, and say, here's what we're going to do, or here's what we'd like to do. You know, how do we get approval? And eventually we would work with them and get it. And there wasn't a company or a country that we didn't get approval for. Some of them we were the first. I think Guatemala, we were one of the first drone providers. Oman, same thing. I don't think the customs agents at that airport had ever seen a drone that big before. At least that's what their eyes told me. They were pretty surprised when I opened up that case. But it was really at this stage where we looked at, you know, how can we build a team for the future now? And that's where we're sitting today. So having this capability of a sound base beneath us has really let us focus on where we want to go forward. And conferences like this are actually pretty exciting for us to participate in. And I think it was Houston, the first one that we came down to in Houston, Texas, that Ron had organized. And it really led me back to thinking about what's sort of the most important aspect of our company and what's made us successful. And it's the people in Pioneer. So it's not the drones, it's not the sensors. It really is that culture and the ownership that all of us take in providing really high quality service and solving problems. And there's, after 9 years of working with the same 4 guys, you think there'd be some grievances, but I'd have to say it's one of the funnest, most rewarding experiences that I've ever been involved in, how all of us are problem solvers. And there's not a thing that comes across our desk that we don't look for solutions for instead of complain about the issue. And that's just a fantastic environment to be in. And it really has fostered growth in that sense. So maintaining that workflow, the management structure and task division, as we grow, we sort of segregated our duties a little bit. So we're each handling something different to be able to take on the workload. And we also focus on investing back into things that work for us. So UGCS, for example, has been a great ground control software. Early on, we got in touch with Alexi and we said, hey, we'd love it if you guys could develop this tool and this tool. And a lot of those are in your guys' UGCS platforms now that you're benefiting from as well, because we work directly with them to improve our abilities. So the GEM Systems has been a fantastic partner to work with, Blacksphere Drones, Phoenix LiDAR. They're all companies that we got involved with as third-party sensor providers or service providers to us, not because of the products, well, partly because of the products, but also because of the ecosystem behind them. So that support ecosystem. And the drone sector is evolving so rapidly that if you have a system that's not quite there for your needs yet, but the team behind that system is very capable, that's what we've sort of directed our efforts into and supported, because we know that we can work with them to get the hardware to where it needs to be for us. And so that's been sort of our ethos of adopting new technology and bringing new technology into the company. But excitingly, it's not necessary for us to drive that so much anymore, because there's now sensor manufacturers that are focusing on developing new drone-based geophysical sensors. It's not us banging on a door, say, build us another mag sensor, or can you guys do VLF, or do you have a solution for radiometrics? We have a couple clients asking. Now there's just a bunch of stuff out there that you can go and rent or buy. And that it goes for the sensor manufacturers and sensor types, but also the drone manufacturers. There's a lot of customization for specific payloads. Blacksquare is building a drone for hyperspectral sensors specifically. And these are just some of the pictures here. So that top one with the black line, it's kind of hard to see, but that's a radiometric sensor. And then hyperspectral there in the middle, the Air VLF that GEM Systems has, the Air Grad, that's the gradiometer mag on the bottom there. That big arrow looking thing, and Milnar hyperspectral sensor built by HiSpecs in Norway. So all of these sensor types are something that's new on the market, and we're all pretty fortunate to be able to be at this stage where you don't have to go through, paying off a drone by sorting gold in a shipping container anymore. You can literally go out and buy a solution off the shelf that can serve your client. So that's an exciting stage for the industry. And I think it's in part to all of us just sticking in this and supporting that to see that grow organically from, a lot of people in this room, to be honest. So just as a quick summary here, some of the sensors that just Terra Plus has for sale and for rent are the drone mag, that's a total field mag sensor, the Airbird, and Air Grad, so that's a gradiometer sensor. Air VLF, this is a dual coil VLF. You can find out more information from Mike Wilson up there. Radiometrics, there's a sensor from them for radiometrics. You guys saw another one here in an earlier presentation. The GEM2 UAV, that's EM sensor. And then hyperspec, there's a couple of them from Headwall Photonics. There's a couple from High Specs. There's a couple from, I think, Ocean Optics or Base Spec. There's multiple hyperspectral, both V-near and SWIR, which is actually allowing us now to do quantitative mineral mapping at a scale that's never been feasible before. So there's a picture on a few slides or a few presentations ago of a satellite, likely Aster data or something similar. Those pixels are quite large. You're looking at like 30 to 50 meters or more per pixel of hyperspectral data. So if you're all mapping alteration patterns with the VS620, that sensor on the heavy lift drone there, that's getting you down to centimeter scale hyperspectral data that's quantitative. It's the same sensor that the USGS uses to build their mineral catalog, hyperspectral mineral catalog. So it's got some legacy there in geological applications for sure. LiDAR sensors, like I mentioned, we fly a lot of LiDAR now. Very rarely do we hang the sensor off of a drone, partly just because of the cost of the system and our aversion to risk there. The LiDAR sensors that we have are well into the 6 figures cost. The amount of resolution we can get those pretty spectacular. So we just flew and have a picture of it at the end, a LiDAR survey over a forested valley in BC, and they're looking at floodplain mapping. And if you look at it from the surface, it's just like a nice smooth forest in a little gentle valley. But stripping all of that back, you can see just a phenomenal geomorphology of that river system, braiding and sweeping around with a bunch of present day infrastructure built along its banks that poses a serious flood hazard risk. And that's why we were there doing the mapping. UAV mounted gamma ray spectrometry. There'll be some demos of this tomorrow, I believe. We did some tests a couple of years ago with hot samples from the SRC in Saskatchewan. These were Athabasca Basin uranium samples. And the drone sensor worked as a solution to detect them. It's in its infancy in terms of getting that data, processing it, and producing a quality product for clients. But in specific cases and certain flight parameters, it's definitely a viable solution for a new drone sensor type. Hyperspectral imaging, again, a fairly new tool for a drone. It has a pretty complex data acquisition, processing, and analysis workflow. But the quality, the resolution, and the spatial resolution of that data, but also the spectral resolution. So if you're imaging stuff from space, sometimes those lower reflectivity minerals like chlorites and other darker minerals don't get the same response as you would having your hyperspectral sensor quite close to the ground. You can map out minerals that you wouldn't have been able to detect, say, from the Aster data set. So that's pretty exciting for us. And then VLF, where are we headed? So these sensors are sort of, I'd say, in like the next class of sensors. So the VLF, there's the AirGrad, the hyperspectral, those are all multi-kilogram sensors. Like the hyperspectral package is around 8 to 10 kilograms or more, depending on the gimbal. We're looking at systems that need to be able to pick up 20 pounds or more of payload. And this is where these custom heavy lift, longer endurance drones are really starting to meet that demand to be effective. So some of the important lessons that we learned along the way is that safety makes us money. So if you reduce the risk, accidents leads to reduce the risk and the accidents. This leads to increased production, lower costs, and more reliable service. So don't look at safety as another thing that you have to deal with. Look at it as a way to make your business more efficient. And it's honestly one of the biggest downstream benefits that we've had. Data quality is paramount. So again, no one cares that you flew the survey with a drone when they're on their desktop looking at the data. They want good quality data. So focus on that as your deliverable. and keep pace with innovation. Build relationships with your sensor manufacturers, support your peers in the industry, and give new things a try. You know, fly a sensor. If you can't afford it, call the manufacturer. Say you want to do a test. They're pretty open to work with eager companies, and never give up. So I wouldn't be here today if we had just said no after those 15 or 20 drone crashes that we've had along the way. So never give up. Lessons from failures can lead to success, and always look for solutions.
Is this on?
Yeah, that was from yesterday. Yeah.
Anybody have any questions? Michael, were you serious when you said you had 20 crashes?
It could be more, but
okay.
So I mean, it's 9 years, right? I don't think there's one person in here that has flown drones commercially that hasn't had something crash on them. So if
Absolutely.
you don't, I won't ask for hands, but if you don't put them up, you'd be lying.
Right. When I'll say a couple of years ago, Dennis called me and he was asking about drones and safety and crashes, and I chuckled because everybody that's been in the drone business knows when you put the aircraft up, there's a good likelihood you could have a crash. And all of us who have been in the commercial business have suffered through the pain and agony of a crash. And fortunately, what's that? Well, one day. And it's really, sometimes the crashes are pretty minimal. And I find that once I have a new drone pilot, if I get him through a little minimal crash, he's much more calm, and the likelihood of a crash after that is fairly has been minimized. And it's really about the fact that we're dealing with something that you know, the physics of it is that that the earth sucks in some days and tries to pull your sensors to the ground. So any comments or questions about Michael's talk? By the way, Michael, I got to say that was a great talk.
Yeah, I appreciate it.
Really
Thanks.
enjoyed it. So.
I always seem to have a question. Okay. With dealing with the hyperspectral sensors and putting that on the UAS, what is maybe one of the biggest challenges that you had to overcome either in setting that up or dealing with the data afterwards, besides maybe the cost of the sensor?
Yeah, that's a good question. So we don't actually own the sensor. We have a relationship with HiSpecs, and we've been fortunate enough to get our hands on it when it's in North America for different demos and fly it here and there. And so I would say that some of the biggest challenges with drone-based hyperspectral, if you're used to doing other things like photogrammetry or mag or other sensor types, you're flying the drone fairly fast and you're getting a lot of production done. The way that the push-through sensors work and just the spatial resolution with hyperspectral, you're flying at like 120 meters or 100 meters elevation, right at the max you can to get your swath wide enough, but you're going at like 2 to 3 meters a second. So it's a fairly slow survey type. You need good weather, clear skies, really high sun angle to get, you know, your maximum insolation or solar radiation. And the sensor has 3 components. It has a V-near, a SWIR, and also a built-in LiDAR, so that you create a high-resolution DEM at the same time as you're collecting your hyperspectral data. And that's the Milner VS620. And that's kind of a revolution because previously you had to collect a DEM as well to put the hyperspectral data onto. Processing is time consuming. The data sets are massive, like terabytes. So for different scopes of surveys, I think the one that we recently flew was one of the largest ones that they've ever done with that sensor. And we're always kind of pushing limits with that respect, but the data quality is very high. There's still, you know, some challenges to get it to final stage, but it's definitely a commercial sensor that is ready to deliver to clients. It's just the time it takes and the cost it takes is just a completely different process than what you're used to dealing with other survey types. It's a lot more laborious, a lot more expensive. Like processing the data is thousands of dollars a day. There's only a few people in the world that really know what they're doing with hyperspectral data in terms of quantitative mineral analysis. So finding those connections and kind of building that ecosystem it took a bit of time for us.
Well, we're pretty much out of time for Michael, but I'll take one more question. All right, you have one?
Yeah. It's a bit of the elephant in the room. What sort of insurance coverage do you need?
So to be honest, with our LiDAR sensor, well, one of them, we self-insure it. It's on a manned aircraft. So I'll go down with the ship if that one happens. But the LiDAR sensors, or sorry, the mag sensors, we self-insure those as well. The problem with insurance is that once you make a couple of claims, the insurance companies just say, no more, you're not insurable. So we carry a significant liability insurance, but for equipment, for an M600, that stuff, we usually absorb those costs. And to be honest, they're very, very minimal in terms of our workflow now. So we suffer very little loss in terms of damaged equipment over the last, I'd say, like 5 years. I mean, all the trials and tribulations were in the early stages of the company.
Very interesting.
Yeah.
Well, thank you again. That was a very good talk.
Yeah, you're welcome.